So when looking at this with the solving the two-step equations, thinking about the way that rope is and how do we get back to the rope we had before we double knotted it. So the rope would be like a single rope with no ties, no knots, nothing in it. And if we tie it up, tie it again, we just double knotted it. And in order for us to undo, we have to undo the last knot first, and then we have to undo the first one. Bless you. All right, moving. So how do you find the value of a variable that has had two operations done to it? So before I do that, let me go ahead and just put a quick box over this so I can go step by step. So it says, how do you find the value of a variable that has had two operations done to it? So not even more than two, because we will be doing ones with more multi-step equations, but just like on the previous page with that rope, we said we had to undo the last operation first, then the first one. Another way to think about this is I have kids write L-I-F-O, which means last in, first out. LIFO, LIFO, whatever. Last in, first out. So I explain this, the best way to explain this, or the way I like to explain it, is if you think of a can, and I'm such an amazing artist, of Pringles. And the reason why I use Pringles is because they stack those chips in there, right? They're stacking them in, and the only time they're ever side by side, right, is if they're broken. But if you have a nice, perfect thing of Pringles, when they put that last chip in, that last chip right on the top, if I want to eat them, which one am I eating first? The last one. I'm eating technically the last one. The first one is all the way in the bottom of that Pringles container. So in order for me to undo what's being done, I'll be taking that last chip out first and eating it and then going all the way back to the first one. So that's basically what it means. The last one in is the first one out. So if I look at my first example over here, for those of you guys who like steps or are visual by reading things and having instructions, in order to solve a two-step equation, number one is to either add or subtract to isolate the variable term. 2 is to multiply or divide to solve for the variable. And then 3, you check your solution. So this first thing here that we have is 3x plus 5, which is equal to negative 16. So if I'm looking at what's my mystery number here? X. X is my mystery number. I don't know what is happening, what it is yet, but I do see that my mystery number is first being, what operation is this? What operation is this?
Multiplied.
Yeah, X is first being multiplied, and then after it's being multiplied, it's being added to give me negative 16. So in order to undo what's being done, first it's being multiplied, last it's being added. So I have to undo the addition before I can undo the multiplication or division. It's like almost in a way, I don't want to say reverse PEMDAS, but it kind of is. You have to add or subtract before you can multiply or divide. So first step, subtract 5. And what you do to one side, you must do to the other. When you subtract 5, you get 3x is equal to negative 21. Undo multiplication with division. We divide both sides by 3. And I could easily just put that little line down the middle, right, that I like to show that what I did to one side I must do to the other. Those opposites cancel each other out. The division cancels those out. And I'm left with x equaling negative 7. And then you can plug it back in to check. Actually, it's always recommended to check. There's no harm in checking. When I plug in -7, 3 times -7 is -21, plus 5 is -16. Any questions so far? All right, let's go ahead and pick and choose just a couple of problems. I did 4 last time, so I'll do 4 again. I'll do this one. So number 3, I will do 6. So I have 3, 6, 8, and 9. So we'll do a couple of these problems together. If you noticed, all of these are multiplication addition problems. So I don't want to do just multiplication and addition. I'd rather have you guys do more when you guys practice on your own with the math space as well. So let's just do a couple. What I typically have kids do in the past, I say x is being multiplied and then added. So I have a lot of kids who will write multiplication and addition and then put an arrow going backwards to show what they need to undo. Undo addition with?
Subtraction.
Subtract both sides, 5. And you get 6x is equal to?
18.
Undo multiplication with? Oh, and 6 divided by 6 is 1, and 18 divided by 6 is?
3.
So the answer is 3, or at least we hope it is. Let's check. 6 times 3 is 18. 18 plus 5 is?
23.
It works. All right, x here is being multiplied and then added, and we need to do the inverse operations and work backwards to undo what's being done. To undo addition, subtract, and I have 7x is equal to 34 minus 13.
21.
Undo multiplication with division. And I have that x is equal to 3. Double check. 7 times 3 is 21. 21 plus 13 is 34. It works. Same thing here. I have multiplication then addition, and I work backwards to undo. I'm going to undo addition with subtraction. When I subtract 18 from both sides, I get that 6x is equal to 6. Undo multiplication with?
Division.
And 6 divided by 6 is just 1. 6 times 1 is 6. 6 plus 18 is 24. It works. And then last but not least, multiplication then addition is happening to our x. We're going to work backwards. Subtract 5. When I subtract 5 from 104,
99.
and then I have to undo multiplication with,
Division.
and 99 divided by 9,
Is 11.
and we can check that plugging it in. 9 times 11 is 99, plus 5 more is 104. So these are the examples, and there is a math space that is posted for this as well.